Hi, welcome to LeetCode. In this, we will discuss LeetCode problem 3372. Maximize the numbers of target nodes after connecting trees 1. So there exist two undirected trees with n and m nodes with distinct labels in the range 0 to n-1 and 0 to m-1 respectively. So you are given two 2D integer arrays, edges 1 and edges 2 of length n-1 and m-1. So this is a non-cyclic, right? So respectively, where edges I indicates ai comma bi, so that indicates that there is an edge between nodes ai and bi. So this is undirected, so that's why you can go a to b and you can go b to a also in the first tree, and similarly for edges 2 indicate ui and vi, that indicates n is between two nodes ui and vi in the second tree. Edges 2 indicates for the second tree or edges of the second tree. You are also given an integer k. So node u is target to node v if the number of edges on the path from u to v is less than or equal to k. So note that a node is always target of itself. Return an array of n integers answer, where answer I is the maximum possible number of nodes target to node I of the first tree if we have to connect one node from the first tree to the another node in the second tree. So for this example 1, our graph is look like this. There is edge for this is the tree 1 and this is the tree 2. Okay, so the first edge is between 0 and 1. So 0 and 1 for the tree 1. So 0 and 1. So there is an edge between 0 and 1. Next is 0 and 2. Next is 2 comma 3. Next is 2 comma 4. So this is the graph of the tree 1. And similarly for tree 2 is similarly for this 0 1 edge between 0 and 1. Then 0 to 2. Then 0 to 3. Then 2 to 7. 2 to 7. Then 1 to 4. Then 4 to 5. Then 4 to 6. Got it? So we have to actually return answer of length n. N is what? N is the number of nodes in tree 1. Correct? So here number of edges, number of nodes in the tree 1. How many actually nodes are there? 5 nodes are there. So you have to return our answer will size will be 5. Correct? Because here n is equal to 5 and m is equal to how many nodes are there? 8. Okay, so you can check our answer length is 5. Okay, now we will check how actually getting the output. So that's different thing. So output size is here actually 5. Got it? Now for this indicate I is equal to 0, that indicates for the tree 1, you can check they mentioned here node I return the maximum possible number of nodes target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. So we have to find out that I is equal to 0 node for the tree 1. How many nodes are there? How many actually nodes can be target of this node, current node I is equal to 0. So after connecting one node from between tree 1 to tree 2, so what actually I can actually connect? I can connect 0 to 0, 0 from the tree 1 and 0 from the tree 2. For this is okay. Suppose this is the I have connected this. So what will the graph will look like? 0 1 2 3 4. Then I have connected this 0 1 2 3 4 7 5 6. Okay, now we have to find out how many actually nodes are there. If we connect this node, this is the newly added edge. So after this connection, how many actually nodes are there to be connected for this node 0? So target will be what? The number of edges between u and v is less than equal to k. Then this can be our, we can say that this u is a target of this. So after this, for this node, how for 0 to 1, how many actually edges are there? Only one edge there. So this is one possible target can be. So 0 can be one target from 1. Next is 0 to 2. Yes, there is also one edge only. Next is 0 to 3. 0 to 3. How many actually nodes are there? Edges are there? 1, 2. 2 edges are there. This can be possible because k is equal to 2. So now 4. 0 to 4. How many actually edges are there? 2. So this can be one possible target. Next is for this 0 to 0. So number of edges is 1. So this can be one possible. For this 0 to 1, number of edges is 2. So this can be one possible. Next is 0 to 2. For this edges is 2 again. This can be one possible. For this 0 to 3, number of edges is 0 to 3 is number of edges is 2. Now 0 to 7, 0 to 7, 0 to 7. This can be possible? No. Number of edges is 3. So this can't be a target. Similarly for 0 to 4, this can't be possible because there are the 3 edges. So below the nodes they also not possible. Correct? Now how many actually nodes are there to connected to be target? So 1, you can check 1, 2, 3, 4, 5, 6, 7, 8, and one possible. So that's why our answer for this will be 9. Okay, this is for 9. You can check the answer is here is 9. We have to maximize this value. So now what actually possible, actually brute force approach, what actually we can think. First of all, we can connect. Here actually we have connected 0 node from the tree 1 to 0 node of the tree 2. We can connect from 0 node from the tree 1 to 1 node 1 to the of the tree 2. We can connect this. Then actually we can actually calculate what is the maximum number of target can be possible for the node 0. In this way, actually we can actually connect all of this in, because we can connect also 1 to 0. This 1 to 0. This 1 to 0 we can also connect that. Correct? Because we can connect any two node. One node from tree 1 to 1 to tree 2. So after all this connection, we can actually check, calculate what is the maximum target can be possible. So for each node n, for each n nodes, we can connect m nodes from the tree 2. So the number of possible is n into m, and for each possible I will check maximum target possible. Correct? So for this time schedule will be like n into m, then what are the like n, this is for L, linear time sorting at least, because we have to traverse at least like how many nodes are there. So that's why that time schedule will be n into m into L. So this will be always nq. So this will give the TLE. This brute force approach is clear? Correct? Now how actually we can optimize this? There are some observation you can think. Now they mention that suppose this is the graph for tree 1 and this is the suppose tree 2. Okay, tree 1 and tree 2. So they mention that after we can connect any one of these, like we can connect these two node. Okay, these two node. Now after connecting, we have to find out the maximum target node possible. So if I connect these two, then how many actually, suppose we are trying to find out what are maximum target possible for node 0. So if we connect these two, so here already one edges will be added, and there is one added for this new extra. So how many actually edges are possible from this node distance? This will be k minus 2, k for this, but we have already taken two edges, one for 0 to this node, then newly added one. So that's why we have to find out this from this node, how many actually nodes are there that can be targeted with the distance k minus 2. Correct? So now we have to maximize this, right? We have to maximize the target node of node 0. Now if I connect this two node, this 0 and this node. Then what will be the edge I can actually calculate here? Actually you can check for this. I can actually calculate. I have taken only one edge here, and here will be I have to check k minus 1. So this, so if I check how many actually nodes are there at a distance k minus 1 from this node of distance k minus 1, this will be always greater than equals to greater distance k minus 2. It may be possible that there is no node of distance k minus 1, but at least it should be equal, greater than equal to k minus 2. Got it? So that's why if I have to maximize the number of target nodes, then we have to maximize this value also, k minus 1, and then that's why we have to always take the k minus 1. We will try to add this new edge at a distance k at optimal node. Optimal node means what? That node actually have in the tree 2, that node actually have the maximum number of nodes that are distance k minus 1. If I just suppose here actually k minus 2 is equal to for this node, how many nodes are there at a distance k minus 2? Suppose 10. Okay, and how many nodes are at a distance k minus 1? Suppose 11. Okay, and at a distance k it is suppose 12. It may possible, valid. Now if I add this edge, then what will be the maximum number of target nodes possible? Whatever actually this is constant, whatever the target node possible from this tree 1, this is constant, we can't change this. But what we have to maximize this, whatever the maximum number of we can be target from here actually, because we can add this node can contribute for this tree node 1, node 0. So what I will try to add this edge at optimal distance that will give the maximum number of node from this tree 2. So that's why I will add this new edge to that particular node from the tree 2 that actually have the highest number of actually nodes that actually at a distance k minus 1. This logic is clear? Like this is constant for this tree 1, for this node 0 we have actually x number of target node possible for this node 0. This is always constant, we can't change this. Can we change? No. But if I add something y that is actually contributing from tree 2, if I have to maximize this y, how can I actually maximize this? If I maximize the number of node that are at a distance k minus 1, k minus will be the minimum maximum value, because I have to at least add one edge that always decrease by value k value at minus 1. So that's why I will check whatever the node actually have maximum node that at distance k minus 1, that actually I will just add this new graph, new edge. Clear? So that's why I will calculate maximum target possible from tree 2, maximum target from tree 2, that I will always try to like for 0 I have already calculated this will contribute the maximum number of nodes at a distance k minus 1. Okay, suppose we have already add this edge and we have taken the value. Now for this node next time we are trying to find out the maximum number of target nodes. So I will add this new edge, because this will add the one edge, and ultimately we are again here for the distance k minus 1. Got it? In this actually, if we actually maximize this will give our total maximum value. Got it? So that's why first find out the maximum target, maximum number of nodes at a distance k minus 1 in the tree 2. Got it? Now what we'll do, I'll always add the new edge from tree 1 to tree 2 at this node particular. This is the maximum tree 2. So this will be always added into the target node. Now what we'll do, for particular node I will check that how many actually nodes can be targeted for this particular tree 1. Like suppose I got x, so I will x plus maximum t2. This will be the maximum number of target possible for the particular node I. Got it? So I have to iterate this for each node I have to check I is 0 to n minus 1. Got it? For each particular node I will check if I how many can be targeted for this 0, then I will check how many targets are possible for 1 and similarly for 2. So I'll check for tree 1 for this particular node, tree from tree 1, and tree 2 is constant, whatever the actual distance present at the distance k minus 1. K minus 1 concept is clear. How we are getting the k minus 1 and why not k minus 2 or anything. Correct. Now go to the code, it will be easy. So first of all, we will find the number of nodes present in the tree 1 and tree 2. So they mentioned that n minus 1 edges will be present and m minus 1. So that's why I have added plus 1. Okay, so this is the, now build the graph edges. So first tree will have n1 number of nodes, and for the tree 2 will have n2 numbers of nodes. So first of all, traverse the edges 1. So u v, and similarly for v to u, I will just building the graph. Similarly for edges 2, I am building the adjacent 2. Similarly for u to v and v to u. Now what I have to find out? I have to find out the number of node, maximum node possible from tree 2 at a distance k minus 1. At a distance k minus 1. That's why I am trying to find out that if I start from that I is equal to 0, if I trying to find the I is equal to 0, how many nodes are possible can be targeted at a distance k minus 1. Okay, so I'm starting from I is equal to 0, I less than n2, because all can be a target node. So that's why I am iterating and trying to find out the maximum possible node. So I have taken a maximum 2, that is initially 0, and I am calling the DFS function that will return the maximum number of node possible at a distance k minus 1. Okay, so that's a DFS of, I am calling the I current node, parent is minus 1, and adjacent list adjacent 2 for the tree 2, and k minus 1, because here actually we have to find the maximum node at a distance k minus 1. Correct. So after that I will find the maximum 2. This will store the maximum number of nodes present at a distance k minus 1 from the tree 2. Got it. Now what have to find out? We have to find out that for the answer, that will be initially from 0 to I less than n minus 1, less than n1, because for each node of the tree 1, we have to find out that how many node can be a target node for this particular I. Correct. So that's why I will check how many for this tree 1. I am calling this again DFS function for the tree 1. Here is passing the adjacent 1, list the graph for the tree 1, and I am passing what I, the parent is minus 1, and here actually I am passing the k at a distance k for the tree 1, and maximum 2 I have already calculated from here, that is distance k minus 1. So that's why I am adding extra maximum 2 value into this answer, particular ith value. Logic is clear, and at the end return the answer. So DFS, what actually it actually do? It actually return how many actually nodes are present at a less than equal to k. So if k less than equal to 0, I have to check this, like it may possible that they have in the constant they mentioned the k can be 0. So there is no nodes at the distance k minus 1. K minus 1 means 0 minus 1, it will be minus 1, no node will be present. So that's why I have to return 0 that time. And else if it is 0, k is equal to 0, that time return 1, means 1 node is present. And currently current is equal to 1 means what they mentioned that current node, it can be itself a target node. So that's why current is equal to 1. Now I am traversing the never node of the current node adjacent I. So if the current node is not equal to the parent, so that's why if it is not in loop, so that's why I just to handle this, I have just added this condition. I am calling the DFS function again. I am passing the current node j, parent as the current node I, and adjacent and the k minus 1, because I have already added one edge. Correct, already consumed one edge, so that's why I am decreasing the value k minus 1, and at the end return the current. What actually it is storing? Current is storing how many nodes are there that are distance less than equal to k. Got it? So here actually passing the k minus 1, or actually calculating the maximum number of nodes from the tree 2 at a distance k minus 1, and here actually passing the k, or trying to find the how many nodes are possible in the tree 1, that actually distance less than equal to k. Got it? And add both of these. Got it? And return answer. It is clear. This concept actually like most important, how actually getting the k minus 1 from k. from the tree to how, like in brute force approach, we can actually connect all the edges and check what is actually the maximum contribute it can be, maximum target node. But how actually optimize this is important. Like we already calculating k minus 1 from the tree 2, and we will take the edge here directly to take this maximum value. Got it? Thank you.